Hello students, welcome to this video tutorial on subtracting integer supernote, part C, method 3, old school. Now, when I learned about integers in grade 7 and 8, there was no method 1, there were no integer tiles, there was no method 2, there were no number lines. We only learned method 3, old school. Okay? So, some of you may like this method and some of you may hate this method, but I'm going to teach it to you anyway. All right, let's have a look at the note here. If given a subtraction statement, try to create an addition statement that gives the same answer. So if you're really good at adding integers, then you're going to love this method. So for example, the question, I have a subtraction question here, positive 8, subtract positive 3. We know that gives us an answer of positive 5. This subtraction question gives the same answer as this addition question. Positive 8 plus, notice how we changed the addition, the subtraction to an addition, plus negative 3 equals positive 5. So what did we do to the original question to make it an addition question? Well, the first thing is, let's have a look at the first integer. Did we do anything to the first integer? No. The subtraction, we changed to addition, okay? And then what did we do with the second integer? Notice what we did? So this kind of leads to the secret of method 3. Rule: the result of subtracting an integer is the same as adding its opposite. Opposite integer is a very important concept in method 3. Okay? So the steps. Step number 1, write the first integer unchanged. Okay, we're kind of used to that, aren't we? Step 2, change a subtraction operation to an addition operation. Step 3, change the integer that follows a subtraction operation to its opposite. 4, solve the new addition question. 5, conclusion statement. Okay, so this is what you need to show me for these solutions. Example 1. So let's rewrite example 1 in standard form. So let me give you a 5-second head start. Okay, so let's start with our steps. Step number 1, write the first integer unchanged. Okay, so the first integer unchanged is negative 8. Step 2, change the subtraction operation to an addition operation. Okay, so this subtraction becomes addition. Change the integer that follows a subtraction operation to its opposite. Well, this is the integer that follows the subtraction operation. The opposite of negative 3 is positive 3. Okay, so like I said, if you're really good at addition, this question is a lot easier to do than this question. Negative 8, 8 negative tiles, plus 3 positive tiles equals negative 5. Okay, therefore, negative 8 subtract negative 3 equals negative 5. Okay, let's go on to example 2. Let's rewrite this as in standard form. All right, so we get 8 subtract negative 3. All right, step 1, write the first integer unchanged. Step 2, change the subtraction to an addition operation. Step 3, change the integer that follows a subtraction to its opposite. Well, the opposite of negative 3 is positive 3. Then we're left with an addition statement. Solve the new addition statement. Positive 8 plus positive 3, 8 positive tiles. We add it to 3 positive tiles equals positive 11. Okay? Therefore, positive 8 subtract negative 3 equals positive 11, or standard form, 11. Okay? All right. Let's go on to example 3. Rewrite this in standard form. This is how we would rewrite it in standard form. Negative 8, subtract 3. All right, let's go through our rules. First integer, unchanged, negative 8. Subtraction operation changes to addition. The integer that follows the subtraction statement becomes its opposite. Positive 3 turns into negative 3. Okay, so we have 8 negative tiles. We combine them with 3 negative tiles. We have 11 negative tiles in total. Okay, therefore, negative 8 subtract positive 3 equals negative 11. Example 4. Let's rewrite it in standard form. Now, when we rewrite this statement in standard form, it becomes pretty obvious, doesn't it? But let's go through our steps. First integer, unchanged. Subtraction operation becomes addition. Second integer after the subtraction becomes its opposite, negative 3. We have 8 positive tiles. We combine them with 3 negative tiles. We're left with positive 5. Therefore, positive 8 subtract positive 3 equals positive 5, or of course 5. Okay? Let's go on to example 5. Positive 5 subtract negative 4. Let's rewrite that in standard form. Okay, so let's try to go through the steps now without drawing these arrows. So, the first integer is unchanged. The subtraction operation becomes addition. The integer that follows the subtraction becomes its opposite. So, you don't have to draw the arrows, but you do have to draw this, right? You're changing a subtraction question into an addition question. So when you got this as an addition question, it's pretty simple. 5 positive tiles, combine it with 4 positive tiles, pretty easy, equals 9 positive tiles. Therefore, positive 5 subtract negative 4 equals positive 9, or 9. Okay, last 3. Let's rewrite this in standard form. Okay, see if you can rewrite this statement as an addition statement. I'll give you a head start. All right, so we're left with 3 negative tiles combined with added to 7 negative tiles equals 10 negative tiles. All right, there's our conclusion statement. Okay, so the last 2 examples are the fun ones where we have more than 2 integers being subtracted. All right, so let's work through this one. Actually, let's rewrite it in standard form first. Okay, the question actually ends up looking quite a bit different, doesn't it? Okay, so let me give you a 10-second head start to rewrite this as an addition statement. Okay, so because every operation was subtraction, every integer after the first integer had to change to its opposite. So in this case, it actually is a little bit handier to draw those arrows. Okay, so what are we left with? 2 negative tiles added to 4 negative tiles. That's -6. -6 tiles combined with 3 positive tiles. That's -3. -3 tiles combined with, oops, sorry, this should be addition, my bad. Combined with -3 tiles combined with -7 tiles is -10. Now, if that question didn't make any sense, then just rewind that part and go through it slowly. Okay, example 8. Now, example 8, I want you to be careful because I've actually thrown in a couple of additions. Okay, so let's rewrite this in standard form first. Now, when we rewrite this question in standard form, it doesn't end up looking a whole lot different. Okay, so for this one, it's going to be pretty handy if I kind of track all of these parts here. All right, so we know that the first integer doesn't change. We have a subtraction. We want to change subtraction to addition. When we do that, the following integer has to change its sign. So +8 has to become -8. Now here we have an addition. We like addition. So we don't change addition back to subtraction. So we just copy the addition. Now because we didn't change this operation, addition stays as addition. This integer doesn't change. We have another addition. We like addition. So we bring down the addition. Now, because we like addition, we don't change the integer that follows addition. We have subtraction. We don't like subtraction. We change subtraction to addition. Because we change this operation, this integer is affected. -2 becomes +2. Okay, so here we're combining the rules of addition and subtraction. Very interesting question. Okay, all right. Let me give you a couple seconds to come up with an answer here. I got -14. Okay, hopefully you did as well. All right, so concluding statement. Let me copy the question exactly how it appeared. Therefore, -1 subtract +8 plus -3 plus -4 subtract -2 is -14. Okay, so thanks for watching all of these videos on the subtracting integers supernote. You made it. So now you have 3 methods to use when faced with a subtraction question. Thanks for watching. Bye.